This is the last lecture of module 4, that is week 4, design of general purpose industrial helical gear reduction unit, and this is part 2. We have already learned how to calculate the gears and bearings, how to select the bearings, and how to make the assess the size of the different shafts. Now, in this lecture I shall cover the development of intermediate shaft. Now, in this lecture first I will discuss design problem, gear data, dimension and first layout that we recapitulate, and refining the drawing of intermediate shaft with followings. Development of gear, end shaft and bearing placement. Next, gear end bearing locking arrangement, use of standard lock washer and nut. Development of pinion end shaft and placement of bearing, and then pinion end bearing locking arrangement, use of circlip, and finally, I will show that possible bearing locking arrangement with housing. Now, if we remember that the lectures are delivered on a gearbox having the transmission ratio close to 39. This detailed drawing will be done on the basis of total reduction ratio, total transmission ratio 24.42, and only change in the last stage reduction ratio. Last stage we had the final stage, output stage, gear was 131 teeth, but now we have taken 82 teeth. So, transmission ratio has that stage has reduced to 5.1 to 5, and for that there is not change up to intermediate shaft, only the center distance in second stage will be reduced and size of the gear will be reduced, which we have not yet calculated the shaft for output. So, there is no problem, and these are the dimensions, and we have calculated all the dimensions of the gears, and center distance in first stage 150 and second stage earlier it was 300, now it is 200, as well as the size of the output gears also reduced, as you see from this chart. Now, already we have made the layout and we have given a shape, a preliminary shape to the intermediate shaft. If you look into this drawing, which is done using AutoCAD, intermediate shaft between pinion and gear. So, first we have find out what will be the what may be the diameter there. It is as we find here the second stage pinion, this one is the second stage pinion on the intermediate shaft. It has root diameter is equal to 55.306. So, we have taken 54, and next in the first stage gear we have drawn, and after that we have also the end after the gear that we have developed. This is a preliminary development to find out the position of the bearing, and from there we finalize the bearing selection, and as well as mainly the bearing selections and loads on the shafts. So, second stage pinion end also the dimensions are we have chosen like this, but in this present lecture I will show you more details. So, these are the dimensions came last time. Last time these were the dimensions, but there is a change while we started developing the intermediate shaft drawing. We found that for locking and other arrangement we had to change design a little bit, and there is a little change in the shaft dimensionings also. Now, first of all, this is the second stage pinion, that what is there we have put it there. Then we have already mentioned that the shaft portion in between the pinion and gear, and if we look into the details, this is, as you see, that after the gear teeth, this is the this one, this is the root or dedendum diameter. So, we have reduced a little bit this diameter. Okay. Now, as you see, this is somewhat 55 point something. So, this we have taken pi 54, just 1 millimeter down, but at the as you see the pinion and the shaft here at this corner, instead of making a just cut like this, we have provided a circular arc, and for which this, as you see, this teeth will be slightly extended at these portions, and if you observe the gears in industry, it looks like that. And here we have provided a chamfer. This chamfer is standardized in company. So, usually here perhaps it is 1.5 into 45 degree, sorry 1.5, this chamfer is 1 into 45 degree to maybe 2 into 45 degree, some chamfer can. This is general chamfer, this is given by a ordinary turning tool. So, these are automatically given, but while you are designing you need to mention that. Now, this portion shown, after that so here it is already discussed that second stage dedendum was 55.3, we have taken 54 here, this dimension we have taken 54, and it is about 10 millimeter gap we have kept, and after that this is shown here further, and then we think of the shaft extended for the gears, for mounting the gears. Now, the gear face width, as you see, this is first stage gear, we have to keep in mind, that is first stage gear will be here, this is input side. So, first stage gear will be here, and that width is 58 millimeter. Okay. And this tape here we have all diameter is 54. Say maybe we can reduce the diameter to 54, 50, even less, 51, 52, and or we can then we will get a shoulder and we can put the gear there itself, say this is the shoulder. Okay. So, that gear can rest there. Now, as such the length of the shaft on which the gear will be mounted, that must be less than the width of the gear. Width of the gear is 58. So, we have taken 56. So, I think this part is clear. Then we will go into the further details. And if we look into this portion, that corner, this corner, what we find some cut is given. Okay. So, this is undercut. So, we have given some undercut, okay, and diameter we have reduced to 46 millimeter, keeping in mind that bearing might be of 45 millimeter, we have just reduced up to 46 millimeter diameter there. Okay. From this key is available, that is rectangular key is available in market with a standard dimensions, and for the shaft size around it might be from 40 to 50. We can accommodate either 12 millimeter width or might be 10 millimeter width also. We have chosen 12 millimeter width keyway, and the length we have taken 45 millimeter. It is multiple, usually multiple of 5 millimeters. And details about the key and keyway we shall discuss when we will make the detailed drawing of the shaft. Now, so what we do, we assemble the gear there, and as you look into this, this is the assembled gear is assembled, and again I will mention that this undercut is given so that this gear touches the shoulder clearly. Now, there is two things are there. One is that although there will be a chamfer on the gears will be given there, but if we keep this corner without giving this undercut, then it might be that chamfer portion will touch, we may not touch properly on this shoulder. So, it will not be able to take the load. This is first thing. Second thing is that if we think of the grinding, then grinding wheel, although this is the grinding wheel, although there is a corner radius, that corner radius is very small, but we wish that this surface of this grinder should not surface this touch, otherwise dimensional will be lost. So, this will move very close to that, but it will not touch, but if we do not give the undercut, then there will be some portion with a circular arc, which again give the problem that gear will not touch the shoulder. Anyway, we can discuss much more in the detailed drawing. Here I would like to mention such undercut is given by a special tool which is available, which is kept aside, and it is put on the multiple to turret type tool stand, and then this can be given. This is a simple maybe 2 millimeter thick, and it will be just depend there. This is apart from that, this also, say suppose without this undercut, your iso stress curve may go like this. Okay. But when we give this undercut, it is surprising that this same curve will improve here a little bit. Okay. So, that is why this undercut is given, and it has a different purpose. Here I have shown that this undercut has been introduced there. So, after that we will think of the rest of the portion, that means the gear end bearing side. Now, we think of the here it is already taken 46, then it might be after that this shaft may be, as I told, it might be on the gears maybe 46 or may even 47. Still we will have 2-3 millimeter shoulder each side, okay, for supporting the gear. Alternatively, we can put another sleeve here just to pass the load. Anyway, then this side, if we think of the 45 millimeter bearing, so we reduced the shaft diameter after the gear mounting a little bit, and then rest of the part we make 45. Now, the question is that why we have taken this much 20 millimeter length, because as in the calculation we have shown that we need to lock this side bearing. We are going for deep groove ball bearing, and we will lock this side bearing, so that this side bearing can take the axial load whatever may be the direction of rotation. So, that is why we have kept a little more place, so that bearing can be locked with the shaft as well as a housing, and that we will understand a little later. So, and this is we have taken 45, and the bearing we have chosen 6309 ball bearing, for which internal diameter is 45 and width is 25 millimeter. So, we have made the shaft accordingly. Now, we put that bearing there, but here a one question, as you can see from this figure, that this bearing, if we would like to lock with the gear, we must put something in between, that is called sleeve or others, otherwise we cannot, this load cannot be transferred there. So, in next page what we are doing, first we put the sleeve. This sleeve is nothing but a, you can say, this hollow cylindrical body, and this length we have taken 20 millimeter, and if you think of the stave up to this groove, there is also undercut. If we look at this portion, there is undercut, and this portion it is less than 20 we have taken, and the sleeve we have taken 20, length 20, so that bearing shoulder touches there. Now, I will show that one. So, now what we do, after putting the sleeve, we put the bearing, and as well as we have also put the locking, the extension of the shaft there for locking the bearing using lock nuts. Okay. I am coming to that next. So, in this slides what we find, that a sleeve is put, so that the axial load is transferred from this side to the gear side, it can rest on that, and now we will lock the outside of this bearing, so that it becomes fully locked, the bearing is fully locked axially with the shaft. So, this for locking what we have used, what we are going to do, we will use the lock nuts, and for that we have made a thread of M45 into 1.5. 1.5 is the pitch, M45 means metric thread 45, and that we have made it there. These details will be shown further in the proceedings of this drawing as well as in the detailed drawing. Now, what is this lock? This is a lock washer. This lock washer is put first, that means on the shaft, not only thread, a groove is made, okay, and this key portion of this lock washer will go here, it will move up to this point, okay, and this groove is shown, it is usually cut by side and face cutter. So, it has go slightly inside, but this can go up to a little bit more than the end of this bearing. Okay. Then we consider the lock nut. This lock nut, it looks like this. This is the inside. This would go inside, and that is the outside. Interestingly, what we find here, we have 4 slots. Now, if we count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We have 17. This is even, this is odd number, and due to that what happens, if you tight a little bit, if you need to tight this knot a little bit, you will find maybe this one is matching with 1, and if you tight a little further, then not the next one here, but another one will come over this slot. So, due to this, this is the outside number is made as many as possible, and it is made odd number. Okay. Now, we shall use this one for locking this. Let us see. So, we have put this one, this lock nut, lock washer and lock nut there, and fully tighten, and after that we have folded. If you look into this, this is folded here. We got one there and we have folded it there. So, this will never open. Now, what we find that on this shaft, after the pinion, the gear key, the key is put, then gear is put, then a sleeve is put, then bearing is put, and then it is locked. So, this portion is completely locked, and it cannot actually, now this gear or bearing, they cannot move on the shaft. Now, again if we come to this side, then we will see that what is the arrangement, still detail. This you have to decide while you are making this drawing, but may not be such details, such undercut details may not be here on the assembly drawing, but a good designer, he always consider that how he is assembling, and he all provide all these things. As you see that the length on the shaft is kept less, so that this sleeve comes to this gear face end, and it touches the gears. And next to that, here we have also put an undercut, so that this grinding can be done properly, and as well as this bearing end also touches the sleeve. And if we observe this side also, there we find that we have also a undercut of things after the thread, so that this touches properly and it can be tightened fully. And this slot is for this washer to go inside, so that it does not rotate. And then we get, after tightening, we get one to fold, and which we have folded here. Now, this undercut, as we have already mentioned, and this is also there is an undercut, and this slot is for accommodating the notch, the projected portion of the washer, so that it does not rotate. This is the locking arrangement. And also this deep groove ball bearing, we have put 6309, and then this part is completed. So, this is the lock washer and this is the lock nut. These are the lock washer number, lock nut number. Okay. Now, the other end, if we look the other end, in that end also first this dimension, if we remember the root dimensions of the second stage pinion was 55. So, after that we have taken 54. What we developed this side, we have taken the other side also same, but there after immediately after that step we can put the bearing. So, close to the bearing we have reduced the diameter to 45. This means that from shoulder is 54 and then shaft diameter is 45. We have got 4.5 millimeter each side, and that is good enough to give the side thrust to transfer the side thrust to the bearing. But in any case we are not going to lock that bearing axially, that is it is such that that bearing is not entitled to take any axial load. Okay. But how we have locked this one? If we go further, we have a circlip there and we have used deep groove ball bearing 6 through 09, and if we make the details looks like that. Okay. And as you see, this is called circlip. Okay. So, this undercut this side also given, so that bearing can sit properly, the grinding can be done as we saw in the other side also we have put a circlip there, and so circlip look like this. Okay. This it is a very thin plate sort of things, inside hole is there and here it is a split. Here it is split, okay. And then it is called nose pliers. There is a circle pliers, special pliers is available. You can enlarge this hole a little bit, and from this side you can put it there. Once you put it, you push it and then you leave this, take the pliers out and automatically it will set there. Now, this actually not necessary in a sense that we are not going to lock that side, but it is better to put such a circlip so that bearing will never go out of the shaft. Okay. So, the other side of the shaft also we have completed. Now, if we compare with the gearbox housing, we should call this one what we have developed so far, not only the intermediate shaft, and as you have put the bearing and as you have locked, whole unit can be called as sub assembly of intermediate shaft. This sub assembly can be mounted separately, not necessarily you have to mount on the gearbox housing, and then whole thing can be this whole this unit you can bring it here and you can put on the bottom cover. Okay. So, this can be mounted there, and similarly the other shafts also will be mounted together, and after that the cover will be put. Now, here so on this we need to think that how we can lock this bearing, which would supposed to take the axial load, that is the gear side bearing with the housing. So, this is one option is that you can on the housing, say this is the housing here, if you look into this housing, in that case it is completely machines. Instead of that, we will keep some portion so that bearing can rest on that while we are boring, and this is the this one is the cover here we have used one cover. So, this cover will touch over there. This means that if we make such arrangement, then this bearing is locked with respect to the housing. So, now whatever axial load coming on this shaft, that will be taken by this bearing. On other side, we simply make a straight cut, and even if this cover which is shown here little bit, this will be shown later more details, but here there will be gap. So, that if there is extension of the shaft or contraction of the shaft, that can move this way and that way, and this is called light drive feet. The housing will be made on this bearing a slight light drive feet. Here also it is kept a light drive feet. Okay. So, I think this is now clear, but we can make also an alternative locking arrangement. So, this is locking with housing, as I have seen this at this point it is locking, here this zone it is locking, but we can also go for, instead of the raised portion here, instead of this raised portion here, we can use a circlip there as well. Okay. So, that is another method of locking. There is due to some people used to go for the raised portion, some people use the circlip, it is like that. But I think it is clear now that how this subassembly of intermediate shaft locked with the housing, and as we need to lock with some material, we have kept some gap here, because we do not know what is the actual surface of the housing, but it is not necessarily we can reduce this dimension further, maybe another 5-10 millimeter we can reduce this. Okay. So, this is alternating arrangement of locking with housing, and now what we have arrived, that as the shaft intermediate shaft subassembly is completed, we have now we find these dimensions, maybe this side, left side it is 56, whereas earlier when we calculated we took it 53, and this one we took 50, instead of that, that has become 62, because here we have made elaborate arrangement for locking, and total length of between the bearing it has increased by about 12 millimeter, which was 178. But still I would say that we need not repeat the calculation of the bearing life, even we need not recheck the shaft design verifications, because this due to this minor change, still there will be change in life, there will be change in stresses, maximum stresses, but that may not be very serious. However, if possible, then a detailed calculation is made on the basis of new dimensions. Okay. So, this is the end of this lecture, and next stage, next week 5 and week 6, we shall do much more on the detailed design of the gearbox housing. Next, probably the output shaft will be made in the same way what we did it here for the intermediate shaft, and then we will after there we will select a bearing, and we will go for the bearing life calculations. We will see that whether it is satisfactory, otherwise we will change again the design, and after that we will take up the input shaft, and that will be also done in the same way, detailed drawing as well as the bearing selection, shaft design verification, etc. So, thank you